This is the outline of my class today. During the first session, we had a brief introduction on basic concepts of statistics, including measurement skills and types of variables. This recorded session is intended as an introduction, and it is for the students who are new to SPSS to get you started quickly and easily. So we are going to start with the basics, where I teach you about the SPSS workspace, how to create variables, and how to enter and clean your data. From there, we will move on to simple statistics and common statistical tests. All right, so let's get started with an introduction to SPSS. Right, so the question here is, what is SPSS? SPSS is a popular program for statistical analysis. It is used often in the behavioral sciences like, tourism, urban planning, but it works well for lots of other fields, So the question here is, why has SPSS become so popular? The biggest strength of SPSS is its user interface, okay, which relies on drop-down menus, making it very easy to teach and to learn as well. So for now, you get comfortable with SPSS software first, and later we are going to learn about theory and research design behind each test. So what is data? Data is a set of observations or measurements taken from experiment, server, whatever, okay, of a specific variable using some appropriate measurement scale. And a data set is a file that includes the data, variable names, and other attributes of the data, such as labels. In SPSS, dataset files end in the file extension .sav. For example, for your thesis file, you can name it like my thesis.sav, okay? So data sets normally are organized so that columns are variables and rows are cases. I will show you later, all right? Now, so after you collect your data, by using appropriate methods, okay, from the sources, the next step is how to extract the relevant and useful information buried in the data for further manipulation and interpretation. So the process of performing certain calculations and evaluation in order to extract relevant information from data is called data analysis. All right. So the letters SPSS used to stand for a statistical package for the social sciences. SPSS was created for social sciences like psychology, sociology, health, and human services way back in 1968. In 2009, SPSS was purchased by IBM, and it is now used in a variety of fields other than social sciences. So the letters no longer stand for anything, and its proper name is now IBM SPSS Statistics. This introduction is for, those students who had little to no experience with SPSS. All right. So once you click on SPSS software icon, on your computer, let's do it together, okay? So I just click on my SPSS software icon, all right? So when the splash page pops up, just dismiss it, and then we can get to work like this, okay? Just close this, and then we can get to work, all right? So there are two main views in SPSS: data view, as you can see here, data view and variable view, okay? Data view and variable view. Data view, which we are in right now, okay, this window is basically just a spreadsheet, and this is where you enter numbers or codes, okay? This is where you enter numbers or codes. In data view, columns like this, you see, are variables and rows are cases. So columns are variables. VAR is a short name of variable. And this 1, 2, 3, 4, 5, they are cases. Each row represents one participant or subject or case or whatever, and each column is dedicated to a single variable. Okay, so right now, as you can see here, all cells are gray, right? All cells are gray. Let's just try typing in some numbers. I will do, 1, 2, 3. All right. Okay, like this. 1, 2, 3. So you will see that as you enter a number into a column, that column comes to life like this, right? Comes to life. So the variable automatically gets named. Okay, as you can see here, automatically gets named VAR0001. All right, so this means variable 1. Okay, this stands for variable 1. If you type in more numbers, more variables get defined, maybe 4, 5, 6, maybe 8 and 9. Like this, maybe 1, 2, 3. Okay, I just type in, okay, whatever, for example. All right, so now we have 4 variables here. So the default names will be VAR0002, VAR0003, and 4. And this can get a little confusing, right? Because it's VAR001, 002, it's like that. So this can get a little confusing, especially if you have lots of variables and they are all named almost exactly the same thing. And also, the default properties for each variable may not be exactly what you want. So we should learn how to change them, how to change the variable's name, right? So to make it more specific to that specific variable. To get to variable view, click on this tab. You see here, click on this tab over here at the bottom of the screen, and then you will get to variable view. So we can now see our 4 variables, right? Okay, as we have entered number over here, once we go to variable view, we can see all of our 4 variables over here. In variable view, each variable is in a row. Okay, variable 1, 2, 3, and 4 is in a row. And the properties are in columns. These are the properties or attributes of each variable that we need to modify, right? Based on that specific variable. We will begin by changing our variable's name. Okay, so there are a few things that you need to know about naming variables in.
We have discussed already this, okay, regarding our variable. We have two views in SPSS, data view and variable view, and this is data view. This window shows data view, and this one shows variable view. And in order to change the name of our variables, we need to follow some criteria. Okay, so first of all, you can name a variable pretty much anything that you want. But you cannot use spaces. You cannot use most special characters like this one, you see. And the name cannot begin with a number. Cannot begin with a number. Variable names must be unique. Let's say you cannot have two gender or maybe two question one, Q01. No, you cannot have that. And your names have to be 64 characters or less. Okay? Now, if you want to use a space, you cannot use a space, okay, in order to name your variables. If you want to use a space, you can use an underscore, as you can see on this slide, underscore, or you can use camel cases, okay? Camel case works equally well where you want to omit the spaces, all right? Instead of using underscores, you can capitalize each new word, right? Okay, so let's go to SPSS, to our SPSS. This is our variable view. So let's change our variable's name over here. Okay, the first one, I want to change it to ID. Okay, because usually the first variable in SPSS or in your questionnaire will be reference number or ID or identification number. So I just put ID and enter, press enter. Okay, you can also follow me. So next we will have a variable name nationality, maybe nationality, and then press enter. Next we can have maybe race, all right, maybe race. And next, let's do like, gender. All right, we are done with changing our variables names, okay? Now variable names are good, but sometimes you want something, even more descriptive, and in that case, you can add a label on this column, you see, okay? You can add a label. Okay, for example, ID is a random identification number. Maybe you can add something like that, and so on. Okay. Another important property here, the next is type, as you can see here, right? Another important property is type. The default type is numeric, as you can see over here, right? Because we are using numbers, but you can change the type, okay, to, for example, dates, if you are recording dates. Or maybe you can change it to a string. You can see here, we have few options over here, right? We have numeric, we have a string, we have data. But the most common variable types that we use in SPSS are numeric or a string. Okay, numeric or a string. The default is numeric, but sometimes in some cases, I will teach you later, okay, and that you can use a string. You can use a string whenever you have some open-ended questions, or maybe you want to type something, okay? You will use a string and you will add the number of characters over here, okay? But our ID now here is numeric, so we don't change the default. We don't want to change the default. Nationality, race, and gender also, we just keep as numeric. All right, okay. So next is measure, which is very important. Okay, I want to explain to you measure, and then I will explain one by one all of these columns, okay? Measure. So measure is another important property that we need to change based on the nature of our variable. Measure specifies the scale of measurement that you will use. As we have discussed earlier during our first session, there are 4 scales of measurement: nominal, ordinal, interval, and ratio. But here in SPSS, you only can see three measurement scales, okay? Nominal, ordinal, and scale. So in SPSS, measure nominal is called nominal, exactly the same. Ordinal is called ordinal, exactly the same. And but for interval and ratio scale, you can choose a scale. It is called a scale for both ratio and for both ratio and interval scales, you can choose a scale. Referring to our variables over here, our ID is nominal, so we choose nominal. Nationality again is nominal, we choose nominal. Race again is nominal. It's just name, right? Can you remember what was the nominal? Okay, I told you that nominal scales are just labels or names. We cannot arrange them in order, right? So we cannot put them in order. So that's why what we call them as nominal scale. So our 4 variables here, all of them, they are nominal. All right, okay, so we choose already our variables over here. So we talk about name, we talk about type, name so far, okay, and okay, what is width? So let me quickly mention okay, other properties as well. Width specifies how wide or narrow the string variable entries can be. The string variable entries can be, okay? If you are not going to use a string variable, so you can safely ignore that, all right? You can safely just ignore these widths, all right? Decimal. Decimals specify how many decimal places will be shown. Okay, so the default is 2. The default of SPSS is 2 decimal points, but for nominal, the nominal variables do not need decimal because they are whole numbers like 1, 2, 3, 4, 5, like that. So, however, for scale variables, we can set to 2 decimal points. So here, all of our variables, they are nominal scales, so you can change them to 0, okay, because all of them, they are whole numbers. We discuss about labels. It's just, you know, just an extra explanation. If you wish to add, you can do that, okay. Let me talk about columns first, and then we can talk about, you know, values and so on. All right, so you see here the columns over here. Column specifies how wide or narrow the columns will appear in data view. Here we are in variable view, right? So in data view, remember I already make it bigger. You can make it bigger or smaller. You can adjust from here, then you can see changes in the columns. Okay, let's see, I want to change this to 20. Okay, for the second variable. And once I go here, you see here the column is now wider. You can adjust in our data view as well, and then you can see changes here in our variable view. All right. Align. Align helps you to set your data to be left justified, right justified, or center. I like to leave all the numeric variables left justified. So I just, you know, I just select left. It's up to you, okay? You can just keep maintain the default one, which is right justified, okay? Now, so here is what you need to know, right? So here is what you need to know. You know already name, type, width, decimal, labels, and so on. You can create a new variable simply by typing a new name, right? Simply by typing a new name, you can create a new variable and give it a label, adjust the decimals, and so on. All right, so I just add one more variable over here. Maybe I just want to add education, maybe education, and then I press enter. Yes, it is numeric, and I don't want to have any decimal points, all right? And then I want it to be left justified. So I will explain regarding the values and missing later on, okay? No worries on that. And then my education can be ordinal. Sometimes education is ordinal, depends on the scales, okay? So this is the new variable over here. And if you want to delete a variable, you can select that specific variable and then clear, okay? Select that specific variable and clear. I want to clear everything over here, okay? I want to clear this. All right, so let's get back to our PowerPoint. I don't know, yeah, over here, okay, to our PowerPoint. So we have learned already how to enter variables in our variable view. So this is how we can work in our variable view. Now, data entry in SPSS. So now, you know some basics for SPSS, right? So how to create a variable and how to adjust its setting. Next, we will take a look at how to enter a real questionnaire, a sample questionnaire into SPSS. And this is something, that a lot of people have questions with. So it's important to make sure when you are working with SPSS that you know how to do it, right? So let's go ahead and take a few moments to look at that. All right. So here I have one questionnaire, okay, on the left side. As you can see over here, I have a questionnaire survey, and later on I will upload this questionnaire survey on eLearn for your reference, okay? We want to key in this questionnaire survey into our SPSS, okay? So now we are going to create a data file. I will upload this later, okay? No worries on that. All right, so let's get started. Our first variable here, I open my SPSS, also SPSS, all right? Okay. So as you can see here, our first variable is ID or reference number, okay, whatever you want. So we have already this ID over here, right? We have this ID here. Now we want to enter, to key in our first session, which is our first section, which is section A, respondents' background information. Let's start with nationality. Okay, let's start with nationality. All right, here. You see here, let me make it smaller so it's easier for you to see. All right. Okay, here. So our first variable here is nationality. I just want to key in nationality. Okay, nationality. Once I press enter, you can see the default over here, right? I don't want any decimal point over here. Okay. As you can see in the questionnaire, our nationality consists of two categories. Number one, code 1 is Malaysian citizen. Number 2 is non-Malaysian citizens, right? Number 1 is like that, number 2. Okay, I want to enter these codes like 1, 2, 3, 4. Of course, I don't want to type Malaysian citizen or non-Malaysian citizen for example, you have 200 respondents. For all 200 respondents, no. It's better we define our categories in our variable view, and then when we are going to enter the cases over here, okay, the respondent responses, we just use number, okay? So we don't have to type anymore, right? Okay. So in order to do that, you can see that there is another column here called values. Okay, called values. In this column, you can define your categories over here. Okay, meaning that if we refer back to our questionnaire, 1 is for Malaysian citizen, 1 represents Malaysian citizen, 2 represents non-Malaysian citizens. All right, so I just put value 1, label is Malaysian citizens, right? And then I just click on add. Okay, next is non-Malaysian citizen, 2 non-Malaysian citizen, right? It's like that, add. Okay, so as you can see here, we have already defined our two categories based on our questionnaire, Malaysian citizen and non-Malaysian citizen, and then we can click OK. Once you click on these 3 dots, okay, what we call that as an ellipsis, okay, or these 3 dots, you can see that all your categories are here, right? Okay, next we want to key in race. Okay, what is your race, right? Race consists of 4 categories over here. Okay, so let's do it together. I just type race and press enter. Yes, it is numeric. Okay, nationality is nominal. Race also is nominal, and then you can choose to be left justified, right? And then here values. Let's refer back to our questionnaire. Based on our questionnaire, we have 4 categories here, right? Number 1 is Malay, 2 is Chinese, 3 is Indian, and 4 for others, right? 4 for others. Okay. So let's do it one by one. 1 Malay, okay. 1 Malay, then 2 is Chinese, then 3 is for Indian, and number 4 is others. And then we just click OK here. So we have defined already our values over here. We have 4 values, which are Malay, Chinese, Indian, and others. All right, here. Now, so as you can see here, for now, we have our 4 possible options. Our 4 possible options, as you can see on SPSS, okay? Our 4 possible options in SPSS. Now, next, say someone checks this one, you see, others, and we ask him or her, please state you are from which country, right? Your race. Okay, so if someone checks this box here as others, they get a 4, number 4, as you can see here, for race, but then they state something. Let's say maybe they state Indonesian, right? They state Indonesian. So whenever we have a box or an entry that people can type something in that needs its own variable. So we need to create another variable for race others, okay? For others race. So now here, in the next row, let's go back to our SPSS. In the next row, row number 4, okay, we are going to enter other race. You see here, I use underscore. You are not allowed to use a space, okay? And then I press enter, okay? So I create another variable for that specific others because we ask people to state they are from where, right? So go ahead and click on our numeric, these 3 dots, okay? This one is a string, okay? Just now I have explained already to you. Whenever we have some open-ended questions or whenever we want to type something, we should choose a string, okay? We need to choose a string variable over here, okay? So we just click okay. Or maybe we can increase the number of characters to 25 and then press OK. So it will be nominal and there should be no value over here. There should be no value over here, okay? So this is how we can deal with such variables like others that people can, type something in there. So this is how we can deal with this kind of variables. Okay, next. Our next question is gender. Okay, is gender. Let's type gender. I just type gender and press enter. Yes, it is numeric. And then I don't want any decimal points here. And yes, I have 2 values. 1 for male, 2 for female. 1 for male, and then add 2 for female, and then add OK. Okay, so missing, no need to add anything. Okay, and it is nominal scale. So, okay, once you want to save your once you want to save your created file, you can go to File, you can go to Save As, and you can choose, the folder. And maybe this one is trial, okay, whatever, HBP. Okay, you can name it, and you see here .sav. This is the default for SPSS, and then just save. This is how you can save your data file. Okay, the one you have created already. Okay, so here, okay, another variable, next variable is age. Okay, so and then you can notice that for age, the respondents are going to enter their age, and we ask for it in years. Okay, we don't have any categories here. We ask age in years. So in such cases, our variable here will be scale. Will be a scale, and we don't have to define any categories under our values column, because they will enter, for example, 22, 43, like that, or 33, or what we have based on respondents' responses. Okay, so we don't have actually any code over here. Let me do it. Age, we have age, just press enter, and then we don't want any decimal because it's whole number. For values, we don't have anything, and maybe we can choose left side, and it is a scale. Why? Because we ask respondents to enter their exact, their exact age. That's why we ask them in years. So that's why we don't have to add any values in our value under our value column. So the rest are also the same as, the first 5 questions. Let's move on to section B. Okay, we want to key in our, these 6 questions or item under social cohesion and trust variable. As you can see here, we have 6 questions from what's called the social cohesion and trust. And here people read the statements, and it says below are, okay, let's say, for example, 6 statements you may agree or disagree with using a 1 to 5 point Likert scale, where 1 represents a strongly disagree and 5 represent a strongly agree. Okay, so answer each of the following as they apply to yourself. Okay, maybe this is some explanation to respondents. Okay, so the first statement on the scale is people in this neighborhood are willing to help their neighbors, like this. You see here, over here, people in this neighborhood are willing to help their neighbors. And then a person will teach maybe 1, 2, 3, 4, 5, something like that. All right. So depending on the level of their agreement. So if someone very much agreed with the statement, then they will choose, 5, saying that they are strongly agree. So now we need to add values of a strongly disagree to a strongly agree for each of these variables over here. Okay, so I will name cohesion all of these 6, right? But as you know, the variable names should be unique, right? So I will follow like this: cohesion 1, cohesion 2, 3, 4, until cohesion 6, right? Okay, let's do it together. Okay, the first one I want to do that is cohesion 1, press enter, cohesion 2, press enter, cohesion 3, enter, cohesion 4, cohesion 5, cohesion 6, enter, right? It's like this. Why? Because we have 6 items under this social cohesion variable, right? Okay, so I don't want any decimal points. You can also copy and paste over here. It's easy, right? Okay, now regarding our values, okay, you can see Okay, let me tell you that all like a scale like this, 1 to 5, they are ordinal scale. Okay, they are ordinal scale. You can copy and then you can paste over here. So all of these 6 items, they are ordinal scale. Okay, now you can copy and just paste over here. I want to add my value over here. We know that our value one represents a strongly disagree and 5 represent a strongly agree, right? So let's do it one by one. 1 represent a strongly disagree, and then I just add. Number 2 is just disagree based on like a scale that we have. And number 3 is just, neither agree or disagree, which is neutral, right? So 4 is agree and 5 is strongly agree, right? Then all 5 values are here and then press OK. Once you click on these 3 dots, you can see that all these 5 like a scale, they are here already. Now, once you do for one of the variables, you can just copy and paste the values for other cells as well, for other, questions as well. So it will, save a lot of time to you. So I just copy this and then I just paste over here. Okay, let's see. I have already everything over here, right? Which is very nice and it will save your time, okay? And I save again the things that I have added, all those variables that I have added, okay? So, so that looks good actually. We can go to our data view. Okay, let's say you have 10 or maybe 300, 200 respondents you can add, and you can also adjust over here. You see here, you can adjust the width of the column over here. Okay, and then maybe you can type 1, 2, 3, I don't know. Okay, 1, maybe 2, and another 1. Okay, maybe raise 1, 2, 3, and 4. Okay, let me show you something now. This one ID number 4. Okay, let me show you something. As you can see, this icon, okay, 1 and a icon over here. Once you click on this icon, you can see that whatever values that you have entered, okay, under this variable view, all will appear over here. And then once again you click on that, it shows both coding and also text itself, okay, the values over here based on the values that we have already entered here. So you can see everything. That's why you don't have to type Malay, Chinese, Indian, others, okay? You just can type 1, 2, 3, 4, okay? Once you click on this icon, you can see the races or maybe all of those, responses. You can see here, right? Responses, maybe 5, maybe 4, like this. Okay, so this is how we can create a data set and we can define our variables, and here we can add all those responses, and with this icon we can see codes and also the values, okay, the interpretation of the values. All right, okay, now we have learned already how to enter cases and also how to enter data in our SPSS. Okay, now next, let's move on. Import data from Excel. Okay, in order to import data from an Excel into SPSS, first make sure your Excel spreadsheet is formatted according to some criteria. Okay, those criteria are maybe the Excel sheet should have a single row of variable names across the top of the Excel sheet in the first row. Let me I show you what does it mean. All right, what does it mean? Let me close this here. Okay, you see here, once you open your Excel sheet, you see, what I mean is like that. First row should show the variable's name. We have ID, gender, age, major, something like that. Okay, and then after that you can import your variable into SPSS. Okay, you need to go to File to open data and you choose your Excel. Let's do it together over here. We can go to File. Okay, we can go to New. We go to, oops. Wait. Let me open again. Let me close this. All right, here. You want to import your Excel, right? You go to File, you go to Open, you go to Data, and then you need to change file of the type of the file to Excel. Okay, so we choose this one, and then we open that. Let's see what happened. No need to change anything. You just follow the default. Okay, and then click OK. Now you can see that all of our variables in our Excel file are here. ID, gender, like this until question 8, right? So as you can see over here, yes, we have ID, gender, age, major, and everything over here. After that, you will need to define each of the labels, values, and measure information for your variables. You need to check all of these measures. You need to check the values and so on. Okay, once you imported the data, and once you go to your data view, you can see that all the data are over here, and we have 48 respondents. Why? Because this one is just a pilot test. Okay, it's like that. All right. So let's go back to our PowerPoint. All right. Okay. So we have explained already this. Once you enter, just now I told you already, once you enter, you import your data from Excel into SPSS, you need to check, you need to modify, do some modification on the values and so on. And also you can clean your data. You can check your data using case summaries or frequency or descriptives. Okay, so let's move on to the next part, which is data preparation. What we call this data cleaning process as data preparation. All right, so data preparation, including a screening and cleaning the data, which is very important. Before you start your analysis, you need to screen or clean your data. So data cleaning and why it matters. Data screening, sometimes they call it as data screening because it brings lots of heartache later on. If you don't go through this, this stage before you start your analysis, it's the process of ensuring your data is clean and ready to go before you conduct further statistical analysis. So data must be screened in order to ensure the data is usable, reliable, and valid for further analysis. Okay, so here, as you can see, over here, you can check whether there are some outliers over here. Outliers refers to really high or low values, okay? And maybe you can check that, value entered that does not exist for that specific variable. For example, you have your variable is gender, okay? It consists of two codes, 0 and 1. 0 is female, 1 for male. Okay, so you can see that there is a coding of 2 under your gender. So it's wrong, right? It's wrong because you don't have code number 2 for that specific variable. So this is how you can check your data, whether it's clean or not. Okay, now one way actually to check the screening, to check your data, you can go to explore. Why? Because we want to find if there is any outliers in our codes or within our responses. What are outliers? Outliers are data points that are far from other data points. Okay, what does it mean? Meaning that there are some unusual values. There are some unusual values in a data set. Outliers are very problematic for many statistical analysis because they can cause tests to either, miss significant findings or maybe distort the real results. So an outlier may be due to variability in the measurement, or it may indicate some errors in data collection. So to detect outliers on each variable, just produce a box plot using this direction. Go to descriptive statistics, and go to explore. Okay, so let's do it together. I will upload this folder, okay, this folder on eLearn. Let's open data preparation dataset, okay, data preparation dataset, and we want to run outlier on the basis of this, okay. We need to go to analyze, to descriptive statistics, and explore. Okay, let's go to our data preparation. We go to analyze, we go to descriptive statistics, and we will go to explore. Okay, we want to check maybe, for example, our variable age over here. Okay, I just select my variable age and then I click this button. Okay, I click on this button and I go to statistics and make sure that your percentiles is checked. Okay, and then I click continue. Then you just press OK. So the results will come up. I want to check this box plot only. Okay, I just want to show you this. As you can see here, our SPSS already detected variable, one case number 12. This tells you case number 12 have, is an outlier, okay, is an outlier. Let's go back to our SPSS again, right? Once we go to our data view, we want to check case number 12. Yes, it is. You see here, our age cannot be 119. Okay, is a typing, is an error when, you are going to type, sometimes will happen this. So once I change, okay, I know that it should be 19, right? We don't have 119 years old respondent, okay, because this is out of the range of our respondents. So I will change it to 19. It should be 19, most probably, right? So again, I will run explore age again, and then I just click OK. So as you can see, there is no outlier detected by SPSS. So my age is clean. So this is the way how you can check all of your variables one by one. Okay, so that's all about cleaning our data. Okay, Let's move on to the next. Okay, so another way in order to check screening and cleaning your data is you can run, you can go again to analysis, descriptive statistics, and frequencies or descriptives. Just now we run explore, okay, in order to see outliers. But now we can run frequencies or descriptives. Once you run descriptive or frequencies, you can check, mean, standard deviation, mean, minimum value, and also maximum value. Okay, so this is how you can understand that whether your data is clean or not. Okay. Next topic is about handling blank responses. How do we take care of missing responses? Okay, if your missing values are greater than 25%, you need to throw out the questionnaire. It's because the results will be biased. Okay, you cannot use that specific questionnaire. But you need to check whether it's only maybe one variable only, just like income. Okay, maybe in Malaysia, people don't like to report their income level. You can exclude that specific variable only. Okay, if this doesn't, affect your conceptual framework, yes, you can do that as well. Okay, so in summary, you need to check your data before you proceed for further analysis, okay, in order to see whether your data is clean or not. All right. So next topic is data transformation, including recode and compute variables, okay? So you may need to transform your data so that you can conduct a specific analysis, including calculating total scale scores, collapsing a numeric variable into groups, and recoding variables. Okay, so let's look at an example of how it works. Okay, here. The question here is that how to analyze a questionnaire with both negative items or reverse items and positive items. Okay, what does it mean? In SPSS, we sometimes encounter variables that are negatively coded, just like PE3. In this example, PE3, meaning that lower values indicate higher agreement. Lower values indicate higher agreement. What we call them negative item or reverse item or reverse coding item. Okay, so although this is not really wrong in any way, positive coding is preferable, especially when reporting means over variables. Most readers naturally expect higher means to indicate something better, not worse, right? Am I right? So in such cases, before we use any statistical test in SPSS, we need to recode our negative or reverse items. Simply, we can go to transform and we can recode those items. Let me explain this to you first. You see here, our scale here is perceived enjoyment. SD stands for strongly disagree. SA stands for strongly agree. The first question is the actual process of using instant messenger is pleasant. So this is a positive question or a positive item, meaning that higher values indicate higher agreement, right? I have fun using instant messenger. Yes, again is positive. But number 3 is using instant messenger bores me, meaning that this is a negative item. Lower values indicate higher agreement, right? Lower values indicate higher agreement, right? It's like that. So in this case, we need to recode code our this item. How we can do that? Okay, let's go back to data preparation. Okay, for example, just think like this. Okay, attitude number 3 is a negative item, and we want to maybe we just open our material 2 data set. We just open our material 2 data set, and then let's open your material 2 data set, and then let's assume that our attitude number 3 is a negative item, and then we want to transfer this negative item to positive item. In order to do that, we need to go to transform, and then we need to go to recode into different variable. Okay, so we need to choose attitude number 3, and then we need to put in this box. So whenever you are going to rename your recording or maybe reverse coding variables, you can add one R over here. This is the way I myself named my own reverse coding variables. Okay, so attitude, exactly the same, attitude number 3. Then you just press change. Okay, now we know that we have 5 like a scale over here. Okay, if I'm not mistaken, let me check one more time. Yes, we have 5 like a scale over here. Let's go to again to transform. Let's go to here. We have attitude number 3, so our attitude number 3, and then change. You need to click on old and new values. Okay, meaning that we need to follow exactly this one. You see, 1 becomes 5, 5 becomes 1. Okay, we need to follow this. All right, let's go back over here, meaning that our old value 1 should be 5 here. Our old value 2 should be 4 here. Our old value 3 is exactly the same 3. And then 4, 2, 5 will be 1. And then continue. Okay, so once we go back to our variable view, to our SPSS data set, we can see that there is one more variable called named R attitude number 3. Okay, then we can adjust other attributes over here, and we can see that our attitude number 3 is over here as well. So this is how we can transform our data sometimes, depending on your questionnaire. All right, now, so how we can transform our data. So let's move on to our last topic in this session, which is reliability test. Okay, reliability test. Actually, validity and reliability, they are 2 concepts used to evaluate the quality of research. They indicate how good are the items to measure the underlying variables of interest. Reliability is all about the consistency of measure, but validity is all about the accuracy of a measure. There are different types of validity, like, construct or content validity. For example, content validity refers to the degree to which an assessment instrument is relevant to and representative of the targeted construct it is designed to measure. For further information, you can refer to the existing resources. We are not going to cover those information over here. So let's get back to reliability. Cronbach alpha is the most common measure of internal consistency or reliability. It is most commonly used when you have multiple Likert scale questions in a survey or questionnaire that form a scale, and you wish to determine if the scale is reliable or not for further analysis. Okay, so as you can see, over here, typically, and in any research, in any research, we use a number of questions, or sometimes, sometimes we use a number of questions. Just now I show you regarding, social cohesion, we had 6 questions, right? Or maybe for perceived enjoyment, we had 5 questions. We have a number of questions that, they what we call them as the underlying items in order to measure a specific variable. Okay, so when we have more than one item, in order to measure a specific variable, we need to run reliability before we create a single score of that specific variable. So reliability tells you if you conduct a study again, will you get the same result? Will you get the same result like this? You see, like this, as you can see on this dartboard, this is reliable but not valid. Yes, you will get the same result. The results are almost the same. They are close together. Okay, but being reliable is not good enough on its own. It should be valid as well. So validity tells you, does the study measure what it is intended to measure? Intended to measure. Okay, so so as you can see on this chart shows both reliable and valid data. Yes, it is like that. Okay, so if you look at top right dartboard, darts are spread out across the whole board. Yes, they are they are going to measure what is intended to measure, okay? But the results are not the same, right? The results are not the same. All right, so this is the definition of reliability and validity. If you open your material to data set, we want to run reliability for 1 or 2 of this variable. This is a model, what they call theory of planned behavior. Okay, let's say our study model is based on theory of planned behavior, which consists of 5 variables: attitude, subjective norm, perceived behavioral control, which are IV, and there is a mediator intention to share information, and the final dependent variable is actual sharing of information. Okay, so let's go back to our material 2 data set over here. Okay, material 2 data set. Now we want to run reliability. In order to run reliability, you need to go to analyze. You need to go to a scale and then reliability analysis. Okay, let's say we want to do this reliability for attitude. As we know, attitude is measured using 5 items. We need to select all these 5 items and put in this items box. Okay, so we have 5 items in order to measure attitudes. And we want to check the reliability over here. Okay, once you click statistics, make sure you tick all of these 3 under descriptives for items, scale, and scale if item deleted. Okay, so that's enough for now. And then we just click continue, and then we just click OK. Let's see the results. Okay, the results here, you can see a few tables over here. The first table, okay, the first table, which is case processing summary, tells you how many valid cases or responses you have. It consists of 192. Okay, that's all. But the most important one is here, reliability analysis and Cronbach alpha. Cronbach alpha. This Cronbach alpha should be greater than 0.7. If this Cronbach alpha value is more than 0.7, you can conclude that your scale is reliable. Okay, but another thing that you need to check is corrected item total correlation. Corrected item total correlation. This one should be greater than 0.3. Okay, greater than 0.3. Let's say sometimes your Cronbach alpha is 0.7, is less than 0.7. So what to do? Okay, what to do? The first thing you need to do, you need to look at this column, Chromebox alpha, if item deleted. If item deleted, it shows you if your item, that specific item, maybe attitude number 1 deleted, you will get a lower, alpha value, okay? But sometimes if the item is not good and your alpha value here is less than 0.7, sometimes you will find, some items to delete. Or maybe you can look at this if your items have corrected item total correlation less than 0.3, you need to delete the item. This refers to the validity, okay? You need to delete that specific item and rerun. Okay, let's say my attitude here, my attitude number 1 here is, it has less than 0.3. The corrected item total correlation is less than 0.3. Okay, so I need to go back to reliability test. Okay, let's say just assume, okay? So we need to delete this item and we need to rerun, okay? And we need to rerun the reliability test. But in our case, all of our variables, they are good variables actually. So I mean, all of our items are good items in order to measure attitude, okay? Once you check the reliability test, okay, so following this reliability test, it is time to add up the items in order to create a single score of that specific variable. In our case, that specific variable is attitude, right? In order to do that, we need to go to transform to compute variable. Transform and compute variable. Now we want to create a single variable for further analysis for that attitude. So I usually name TOT, T-O-T, meaning that total. Okay, this is a short term of total attitude. Okay, and then this is my attitude. Okay, now what next you need to do is you just click on all. We need to find mean because we are going to use to compute our attitude based on the mean values of these 5 items. Okay, so we click this and then comma, and then we need to include our attitude number 2, comma, attitude number 3, comma, attitude number 4, comma, and attitude number 5, comma, and then no need after attitude number 5, just parentheses, okay, just bracket, no need to put comma, okay? So okay, click okay. Then once you go back to the data, you can see that, okay, once you go back here, you can see that there is another variable which is total attitude. Okay, we can do this left, and this one you can use for further analysis. Okay, so this is how you can create a single score. Okay, I already included the results of reliability test for all those 5 items, those 5 variables using material 2 data set. Okay, you can run this reliability test at home, and if you have any question you can ask later on. Okay, so you can check your results with these results that I included, okay, already over here. So our reliability table in report looks like this. Here are our variables name, number of items deleted, if is applicable to your case, and the alpha value we should be more than 0.7. Okay, so this is how we can report that. So this one I already put, how you can create a single variable based on those items. All right. Well, so this brings us to the end of this session. Thanks for joining and your attention. I hope that you enjoyed this session and have a good day. So see you next time. Thank you.